studied, enthalpy change is basically you need to break the old bonds. They need to be broken. So just a quick recap, that all the bonds that you have in your reactants, they have to be, you need to break them, preferably all of them. The easy part is break all the bonds that are part of the reactants, and then form all the bonds that you find in the products. But remember, I told you that you can use bond energies, and bond energies can only be used for gaseous. They're only defined for gaseous molecules. So there's a limitation that we have. So I'm just going to do a couple of more questions. Most of the questions are very easy. So for example, in this reaction, what they're looking for is they're looking for seeing what is the order of enthalpy changes of these reactions from most negative to most positive. So in the first one, I'm going to try and figure out this reaction number P, this P, its enthalpy change. I'm going to try and figure that out. So enthalpy change would be bonds broken. That would be endothermic. So in this reaction, only bonds are being broken. The only thing that's happening is you're breaking a Br bond, which is over here. That is 193. So that's it. And bonds broken. And bond formation, nothing is getting formed. So that is 0. So it's going to be plus 193. That's it. Next one, Q. You've got your a bond is being formed only. So broken, no bond is broken. So nothing is happening there. Formed, there's one ClCl bond that's formed, and the value is given over here. That is 190. The ClCl, that's 244. So that one is minus 244. Then you've got this reaction. Now, in R, how many bonds are broken? I told you break all the bonds in the reactant. So there are 3 CH bonds that need to be broken. So these, I'm talking about R over here. So you've got these 3 CH bonds that need to be broken. And how many bonds need to be formed? It's CH3Cl. Like, you should know what the structure is. CH3. CH3Cl looks like this. So that means you're forming. So the bonds formed are 3 CH bonds, and there's going to be one CCl bond. And bond formation is all exothermic. That would be positive. So CH bonds would cancel out. I mean, they're going to get canceled out. So it's basically one CCl bond that's getting formed. I mean, you could have spotted that the only thing that's happening over here is that the CH3 bonds, overall, nothing is happening to them. The carbon is just adding another Cl to it. So that's one CCl bond that's being formed. So which is why it's going to be exothermic. And the value for that is minus 340. So the enthalpy change is you're not breaking any bonds. The only thing is you're forming a bond of CCl, that's minus 340. Up here, last one. The last one is you're breaking a CH bond. That's what you're doing. So the enthalpy change is you're just breaking a CH bond. That value is plus 410. So anyways, you've got these values and you just have to arrange them in the guide.
Sir, can you explain R again? Can you explain R again?
R is this thing. It's CH3 plus Cl, and it's forming this thing, right? I mean, this is what R is. CH3.
Yes.
So how many bonds are broken? It's I mean, the bonds that are broken, I told you that break all the bonds in the reaction. So it's these 3 C and H bonds. They need to be broken. So 3 CH bonds that are broken, right? And bond breaking is endothermic, so that is positive. And how many bonds are getting formed? Form all the bonds that are present in the products. So it's 3 CH bonds and there's 1 CCl bond. So 3 CH bonds and there is 1 CCl bond. Now bond formation is exothermic, so the sign is going to be negative. So the enthalpy change is going to be the sum of all of this. Bonds broken and bond formation is all in negative because that's exothermic. So kya hoga? What's going to happen is that the CH would get cancelled out, right? I mean, even if you add them up.
Okay.
So you're just left with minus CCl, right?
Okay.
And that's minus.
I understand.
Achha, next is you just have to arrange them in the right order from the most negative. The most negative is, I think, R. So it's going to be C. And the most positive out of this is S. So, I mean, just by looking at the first and the last value, you can figure out that the answer is C. Let's try and do one difficult question. There was one difficult question. Most of the questions are kind of easy. Like if you do this reaction, what's happening here? That there's an X2H6 molecule, and so there's 2X plus 6H. Now the reactants don't have any bonds. Like the 2X. Remember, when you have a coefficient, I mean, it's not a formula. It's so that means I mean, you just have 2X atoms. They're not forming any bonds. You got 6 hydrogen atoms. They're not forming any bonds. And you've got an X2H6 molecule. So the only thing that we can think of, I mean, you need to think what the structure looks like. So X is a non-metal. So it's probably something like ethane, where 1X would be bonded to. I mean, that's the only structure that we know of that even looks like X2H6. And he already told us that it's a non-metal, so it's probably a carbon atom, C2H6. So I mean, that's a best guess. So how many bonds are broken? No bonds are broken. So bonds broken, that is 0. How many bonds are formed? So X, between the X and the H atom, that's I mean, you can count that. Be careful. It's 1, 2, 3, and 1, 2, 3 over here. So that's 6 XH bonds, and there is one X and X bond that's also getting formed. And the overall enthalpy change, these values are going to be negative. They'll be exothermic. So the overall enthalpy change is already given to you. It's they've told us the overall enthalpy change. So it's -2, 7, 7, 5 is equal to bonds broken. That's 0 minus the bonds formed. So XH bond energy is given. So it's -6 times 395. And the other one is -X, 1 into XX. So the XX bond energy is not known. So all you have to do is you have to find the XX bond energy. So I'm just going to rearrange the terms, bring the X and X on the left side. So it's going to be -6 times 395 and -2, 7, 7, 5. This would be actually plus. So can anyone tell me what the value is for this? And which one is the correct option in this case? And is this clear? Bonds broken, 0. Bonds formed, this.
Sir, it's A.
So it's coming out to be A.
No, it's B. It's B.
So I mean, remember, you have to be very careful about the signs. It's very easy to get the calculation part wrong. So be very careful when you're dealing with the calculation. I mean, the rest of the thing is kind of easy, but I mean, people make a lot of mistakes when they're doing energetics questions. Just 1 second. So now the next, so I wanted to do a difficult question. I mean, this question is kind of easy as well. You just have to figure out the bonds broken and the bonds formed. So you'll be able to find the enthalpy change in this case as well. Same is, I mean, you can figure out this one, like how many bonds are broken? It's 2 NF3 molecules. So that means in an NF3 molecule, you will have, I mean, there are 2 of them. So that means a total of 6 NF bonds need to be broken. So that is the endothermic part. And how many bonds are formed? They're just atoms. No bonds are formed. So no bonds are formed, that's 0. So everything should add up to be equal to 1668. And they were looking for the NF bond energy. So only thing you have to do is get the 6 to the other side and you'll get your value. So it's going to be 1668 divided by 6, which would probably come out to be something around, my guess is 278, but you can just confirm. Like 1800 divided by 6 is around 300. This would be less than 300. So it's going to come out to be 278. Okay, is this clear? All these questions, is this all of this, is this clear? So is this clear? Amna, Alicia, is this clear? Mahad?
Yes.
So now let's try and see. I mean, most of the questions are going to be easy. They're not going to. So we did this. We skipped this one. So let's move to a slightly more complicated question, which is this one. Now in this question, and what I'll do is I'll just copy paste this one just a second. To get a difficult question. So I'll just put it on the board. Just a second, let it. Just hold on 1 second. So this one. So I just post it here. The difficult question. Now this one is he's asking a question, but everything is in terms of X and Y and N. So there's so people can get very easily confused with this. So what the question states over here is it states that which process just 1 second. So just hold on 1 second. The board has stopped working.